Hello everyone. Hello everyone, my name is Belinda Ayuna Rahma. On this occasion, I will presenting on the food regulations, specifically those related to the BPOM, SNI, and Codex Alimentarius. So, what is BPOM? BPOM, or the Food and Drug Supervisory Agency, is the government agency in Indonesia tasked with overseeing the safety, quality, and suitability of drug and food, both before and after products are distributed to the public. First, I will discuss BPOM Regulation Number 20 of 2021. These regulations stipulate that the safety of processed food must be ensured not only during the production stage but also throughout the distribution process, all the way to the consumer, through the implementation of risk-based processed food safety management system, or SMPPO, which must be carried out by all business operators involved in distribution in accordance with good manufacturing practice. Implementation of this system is evidenced by SMPPO certificate, which consists of the commitment fulfillment requirements for traditional retailers, mini-market, and market operator, as well as compliance standard for distributor, importer, and supermarket that requires an audit. The certificate is valid for 5 years per business location and must be renewed before its expiration. Once certificate, businesses must form an SMPPO team, maintains a food safety manual, consistently implement the system, conduct internal audit at least every 6 months, report result to the Food and Drug Supervisory Agency, and report food incident, including food poisoning, damage, or contaminated food, and product recalls with a maximum reporting deadline of 24 hours if the incident results in illness or death. BPOM conduct risk-based oversight that consider incident of food poisoning, consumer complaint, violation of labeling and marketing authorization requirement, laboratory test result, and audit non-conformities. Consequently, high-risk facilities are subject to more intensive monitoring, and non-compliance may result in warning, administrative fines, product recall, suspension of certificate, or revocation of business license. Next, still regarding the BPOM, but this time more specifically concerning food additive, namely flavoring. This regulation governs the use of food additive flavoring to ensure they are safe, non-misleading, and controlled, with the aim of protecting the public, keeping pace with advancement in food science and technology, and providing clear guidelines for the industry to ensure that product remains safe and high quality. Food flavoring are defined as ingredients used to impart, enhance, and replace aromas and flavors lost during the production process without providing nutritional value. They are classified into natural flavoring derived from natural starch through physical, biological, and enzymatic process. Natural identical flavoring resulting from synthesis with the same structure as found in nature. Artificial flavoring not found in nature, and smoke flavoring used to produce a smoke aroma. Their use must adhere to safety principles, be used in appropriate amount in accordance with food manufacturing practice, and not mislead consumer. Thus, they must not mask spoiled raw materials, conceal poor production process, deceive regarding quality, or substitute primary ingredient without clear information. Flavoring might also use carriers or solvents such as water, alcohol, oil, propylene glycol, and maltodextrin, which must be food grade and safety. While businesses must use flavoring that meet standard, ensure product safety, and maintain documentation of specification, safety evidence, and quality control system. Labeling must be honest and transparent by specification the type of flavoring, such as natural, nature identical, or synthetic, without implying the presence of natural ingredient if they are not used, while oversight is conducted by the Food and Drug Supervisory Agency, which has the authority to request safety data and impose sanctions such as warning, product recalls, production halts, and administrative penalties. In addition to the BPOM, there are also national standard governing product quality, namely SNI. SNI is a nationally established standard to ensure that a product meets the quality, safety, and standard required by Indonesian regulation. For example, SNI 2973 of 2022 for biscuit products established requirement for quality, safety, ingredient, and production process, packaging, labeling, and testing methods to ensure that products on a market are safe for consumption and maintain consistent quality, with a scoop covering biscuit, cookies, crackers, wafers, and pie or similar dry pastry made from wheat flour or other flours and baked to a low moisture content so that they are crispy and have a long shelf life. The standard mandates that all raw materials be safe, of high quality, undamaged, and uncontaminated, including flour, fat or oil, sugar, and food additive, which must comply with regulation and not exceed maximum limit. It also establishes physical and chemical quality requirements such as low moisture content to maintain crispiness and shelf life, limit on heavy metal contamination such as lead, cadmium, mercury, and arsenic, as well as prohibition of hazardous chemical contamination such as excessive pesticide and mycotoxin. From a food safety perspective, biscuit must meet microbiological limits regarding total microorganism, mold, yeast, and pathogenic bacteria such as salmonella, as well as sensory requirements including normal taste, characteristic aroma, crisp texture, and natural color without any sign of hygiene. The production process must comply with CPPOP standard to ensure hygienic facilities, worker cleanliness, equipment that does not contaminate the product, and effective quality control, while packaging must be food grade and capable of protecting the product from air and moisture to prevent the biscuit from becoming stale. In addition to biscuit, SNI also regulates other products, one of which is green tea under SNI 3945 of 2016. This document establishes standards for the quality, safety, classification, testing, packaging, and labeling of green tea to ensure that products on the market are safe, high quality, uniform, and support trade, with a scope limited to pure green tea that has not undergone enzymatic oxidation and is processed through withering, rolling, and grinding, drying, as well as sorting and grading. This standard classifies green tea into approximately 20 types based on particle shape and size, which determine quality, grade, and market value, while also establishing physical and sensory quality requirements. The appearance of dry tea ranging from dark green to light brown, shape appropriate to the type, characteristic aroma, relatively uniform size, freedom from foreign matter, and infusion quality, producing a color ranging from yellowish green to yellowish red, with a fresh sufficiently strong, with a characteristic aroma free from foreign taste or odor, accompanied by bright green infusion residue as an indicator to high quality, and emphasize that green tea must be natural without any additive. From a chemical quality perspective, the maximum moisture content is 8%, water-soluble extract is at least 32%, total S content of 4 to 8%, crude fiber content of no more than 16.5%, and polyphenol content of at least 15%, to ensure shelf-life and quality, along with limit on heavy metal contaminants such as lead, tin, mercury, arsenic, and cadmium, as well as limit on total microbial contamination, coliform, mold, and yeast to ensure consumer safety. Moving beyond national regulation, we now turn to international standards, specifically the Codex Alimentarius. The Codex Alimentarius is an international food standard developed by the FAO and WHO aimed at protecting consumer health and ensuring fair food trade among nations. Codex Standard 176 of 1969 regulates the quality and safety standard for cassava flour intended for human consumption. This flour is made from cassava tubers and have been dried, ground, and sieved, and must undergo a detoxification process if bitter cassava is used to ensure it is safe for consumption. In terms of quality, the product must be safe, free from any unusual odor and taste, free from impurities and insects, and have a maximum moisture content of 13% to prevent microbial growth. Additionally, the product must comply with contaminant limit for substances such as heavy metal, mycotoxin, and pesticide residues. During production, cassava flour must adhere to food hygiene principles to ensure it is free from harmful microorganisms. Packaging must protect product quality and not react with food ingredients. Regarding labeling, the product must include the name edible cassava flour as well as the manufacturer identification to support traceability. In addition to the product itself, the Codex also regulates the production process, particularly regarding hygiene, as outlined in Codex 23 of 1666. This codex serves as a guideline for hygienic practices in the production of processed food, particularly low-acid canned food, aimed at ensuring product safety and suitability for consumption. Its core principle is to ensure products achieve commercially sterility, with the entire production process controlled from raw materials through to distribution. Raw materials used must be safe, free from harmful microorganisms and toxic substances, and undergo proper sorting and storage process. During production, hygiene must be maintained by ensuring processes are clean, efficient, and prevent cross-contamination while using water that meets drinking water standards. Production facilities must also be designed to be hygienic, easy to clean, and pest-free with non-cross-flow process route. Additionally, workers must maintain personal hygiene, be in good health, and use appropriate protective gear to prevent contamination. The most critical stage is the heating or sterilization process, which must be controlled by on specific temperature and time parameters to kill harmful microorganisms. Afterward, the product is hermetically sealed using clean and safe packaging to prevent recontamination. Furthermore, storage and distribution must be conducted under conditions that preserve product quality, supported by continuous testing and monitoring. If non-conformities are detected, the product must be rejected or destroyed. Additionally, there are regulations regarding microorganisms in food. The Codex 21 of 1997 guidelines establish microbiological criteria for food as a basis for assessing product safety based on the quantity and type of microorganism present, with the primary objective of protecting consumer health. Microbiological criteria are standards that establish specific limits for microorganisms or their toxin, thereby enabling the determination of whether a food product is safe for consumption. Their establishment must be based on scientific evidence and risk analysis and must take into account the type of food, method of consumption, and storage condition to ensure realistic application. In practice, the approach emphasizes preventing contamination from the outset through the implementation of hygiene and food safety systems such as HICCP, rather than relying solely on testing the final product. These criteria also include key components such as the type of microorganism as maximum permissible limits, sampling methods, and valid and accurate analytical methods. Testing is conducted through a sampling system using the lowercase m limit as the safe threshold and the uppercase m limit as the unsafe threshold to determine product acceptability. Additionally, continuous monitoring and evaluation are carried out through trends analysis and periodic data review. Finally, regarding chemical contamination, there are also regulations concerning antibiotic residues. Codex Regulation 2 of 2024 set maximum limit for antibiotic residues in food of animal origin, one of which is cefsiofur, a cephalosporin class antibiotics used in livestock such as cattle and pigs. This regulation aims to ensure that antibiotic residue remaining in food product remain within safe limit for consumers. In testing, cefsiofur residues are not measured as the parent compound, but as its metabolite, dysphoryl cefsiofur. Since this compound is the form that remains in the animal's body, maximum residue limits are set differently for each tissue, like this. Additionally, an acceptable daily intake of 0 to 50 microgram per kilogram of body weight has been established, indicating the amount of residue that is still safe for human consumption daily throughout one's lifetime. This limit is based on scientific studies by JICFA, making it valid and accountable. Residue control is not only carried out through product testing, but also through regulation on drugs used in livestock farming, such as the implementation of a withdrawal period before animals are slaughtered. If residues exceed the established limit, the product is considered unsafe and must be withdrawn from circulation.
Maybe that's all for today. Thank you for watching. I hope you enjoyed this video and see you next time.